In today's video, I will be outlining what you need to do today and also teaching a lesson on the mid-segment theorem. So first off, just wanted to cover today's announcement that today you will complete the assignments from Friday and Monday, if you haven't already, to be prepared for today's quiz. So quiz comes next, so if you have not yet done Friday and Monday's activity, you won't be prepared. They're the same types of problems, like one of each. So it's a heads up when you go to Delta Math, if you're thinking, oh my goodness, that's a lot of problems, it's really not. There are, that's for the third, this quiz here. If you look at this quiz, there's 18 questions, but only the last two are the ones where you really have to set up the equations. All the rest are either identifying things, or you'll either subtract a measure from 90 or 180 to identify an angle measure. So not hard stuff. Today's lesson here on mid-segment theorem, there are only 8 problems. I'll be working out half of them with you, and then the other ones are for your practice. Minimum required today will be to take notes on what I give you in this video, and then turn those in. If you want to go ahead and do numbers 3 and 4 and 7 on your 7 and 8 to practice, you should do so. I do recommend that you do them to better help you be prepared, as tomorrow we will be doing a test review. For Thursday, November 5th, we will be reviewing for your test, which will be on Friday, which will cover the lines and angle stuff and the exterior angle theorem from yesterday, which was Tuesday the 3rd, and the mid-segment theorem from today. So today's lesson, I'm going to go ahead and outline for you the mid-segment theorem. I will have this document available for you to print out in the announcements. So it says mid-segments. So if you think about mid-segment, mid means middle. So I'm going to turn on my annotate tool here. So the middle would be this line right here, this middle line. Let's see if I can trace over it pretty cleanly. So this is the mid-segment of a triangle, okay? It's the segment that connects the midpoints of two sides. So if you think about what that means, this segment is connecting the middle of each side of this triangle, so the left and right side. Notice how we have one mark here and one mark here to indicate that those are congruent, as well as here, okay? So that is a mid-segment of a triangle. So what does the mid-segment theorem tell us? The mid-segment theorem tells us, let me clear what we've got here. The mid-segment theorem is what helps us to solve things. So it says here that if a segment joins the midpoints of two sides, then the segment is parallel to the third side and it's half its length. So it's parallel. So DE is parallel to AB. If you look over here, DE parallel to AB. When you see these two vertical lines, it looks like two lines running parallel, meaning they never intersect. And because they are parallel, some interesting things happen. If we consider that DE and AB are parallel lines and think of line CA as this transversal that we've been talking about, some interesting things will come up, and especially corresponding angles. So I'm going to mark that angle CDE is congruent to EDA. CDE is congruent to CAB. I messed those all up. So these angles here on each side will be congruent. And let me see if I can change color. And that also means that these angles here, I'm going to mark it with 2 arcs this time, CED is going to be congruent to CBA. So I'm going to put 2 arcs here to indicate that these two angles are congruent to one another. That's going to help us when we're solving in our Delta Math assignment. So in addition to that, I'm going to clear this. What it tells us is some information about this mid-segment in particular and about its length. It says that DE is equal to half the length of AB. Half the length of AB. So what that means is, like, let's say that DE has a measure of X then AB rather, is twice as long because this is half. So we can call that 2x. But if that's true, what also is true is that if this is x, then this DE would be 1/2 the length of the base. Okay? So again, if we're given the midsegment, we double it to find the base. And if we're given the base, AB, we would cut it in half to get the length of DE. It's pretty easy statement there. So let me give you an example. Let's say that I tell you that DE has a length of 10. If DE has a length of 10, then AB is twice as long because DE is half. So this would be 20. Okay? Pretty easy. 10, 20. You double it for the bottom. If I tell you that AB has a length of, let's do 8, then what do we know about DE? That we cut 8 in half, and this would have a length of 4. Okay? So that's what we mean when we say that the midsegment is half the length of the base AB. So let me just kind of talk to you about angles. Let's say that we know that CDE has a length of, let's do 27 degrees. Then that means CAB has a length of 27 also. So those are going to be always congruent. And as well, CED would be congruent to CBA. All right? So that's going to help with our work today. So if I move this up and just kind of outline for you, what is the measure of angle VUO in the figure? Let's think about what we know. We know that this angle here is congruent to the midsegment, or congruent to this angle formed by the midsegment. Why? Because N, M, and UV are parallel. So let me just remind you that sometimes you'll see a symbol like a V on these lines to indicate what lines are parallel. So that means UV is parallel to NM, and because these two lines are parallel, if you were to think of NO as a transversal cutting through two parallel lines like we've been studying, then corresponding angles are congruent. So if that is the case, if right here, if NMO has a measure of 65 degrees and we need to find the measure of VUO, it is congruent. So this 65 degree measure would be the same as the measure here. So 65 degrees. Okay? All right. So next, if I talk to you about side lengths, but now we have an expression. Let me go to annotate again. Keep my blue. And they ask us, find the value of x, and we have an expression, not a number. Well, let's think about what we know. If we know that this side 20, this base here is 20, what do we know about the length of the midsegment? It must equal 10. That makes sense? If the base is 20, the midsegment is 10. So if they want us to find the value of x, all we have to do is solve this one equation. Or think, what number minus 4 equals 10? And it would be 14. 14 minus 4 is 10. But we can also find that algebraically by adding 4 to both sides. And when we do so, it would cancel out here, and x would have a value of 14. Okay? So we're going to use this concept, but to solve other algebraic expressions today. So this is like a really, maybe like a middle school level concept of being able to understand that relationship. And today we're going to apply it to being able to solve when we apply these relationships, but we have some equations to solve. So next I'm going to ask you to pay attention as I flip over here to Desmos. And we are going to go through these problems, but I'm going to be splitting the screen and using my document camera. So what I recommend is that you take notes, of course, while we're doing this as well. When I ask you to submit notes, these are the problems I want you to submit notes of. If you did print the sheet that I just talked about and want to include a picture of that, that would be great also. That would be a really good reference. You're welcome to copy down from that, but what I definitely want to see in your notebooks is what I have here on my screen. So just a quick recap that the mid-segment theorem indicates that if we have a triangle with a segment in the middle, oops, so sorry. Let that focus. If we have a triangle with a segment in the middle where we know it's in the middle because these are marked congruent to one another, and then certain things are true. Again, we know that that whatever this is, this mid-segment is going to be half the length. Another way to think about that, by the way, is if this is x, then this would be twice x. That's the same thing. But what else will be true? We know that we will have corresponding angles to be congruent. So I'm going to mark this one congruent to this one. 2 arcs here to show that these are congruent. And same here. So in other words, in theory here, if I draw this triangle, if this measure is 30, so think if I give you x, you double it to find the base. This length would be 60. If I tell you this measure is, of course, these would have to be marked congruent. That's how we know it's the mid-segment. If I tell you that this angle is 25, then this angle is also 25. If I tell you this angle is 30, and make it something different, 33 degrees, then this angle here would be 33 degrees. All right, so that would be good to have in your notes. So we're going to go ahead and flip over here to Delta Math. And I'm going to do numbers 1 and 2 and 5 and 6, because 1 and 2 we are dealing with side lengths, 5 and 6 are dealing with angles, but they are with expressions. And then you are welcome to try 3, 4, 7, and 8. Okay? I know because we gave you a quiz and this assignment today, you might have taken a long time on your quiz, and if you did, at least turn in the notes for 1 and 2 and 5 and 6, and you can always go back and practice 3 and 4 and 7 and 8 tomorrow, okay? But if you'd like to go ahead and knock it out, you're welcome to do that as well. So I'm going to go ahead and click on 1. And it says in the diagram below, and they give you a bunch of information. And that might look like a lot, but don't let that bother you. In your notes, what I'd want you to do is write, for Delta Math, today's date is 11/4, and your assignment is on mid-segment theorem. This is going to be helpful because your test questions will look like these. So if you label it appropriately when you study for your tests, which are always open notes, you can come back and look at these examples here in your notes. All right, so I'm next going to draw the picture. So I'm going to go over here to number 1, and I'm going to draw a picture of what that looks like. Best I can. We don't have to be perfect. I am a math teacher, not an artist, but I am going to try to make sure that however I draw my triangle, that this base, my mid-segment, touches the middle and is parallel. So I'm going to draw a little triangle or angle marks to show that those are parallel. So let's fill in what we know. It says in the diagram of triangle G, H, J, so I'm going to go ahead and label my letters as well. What do we know to be true? They tell us that GH and K is a midpoint of GH, so that means this is congruent to this, and L is a midpoint of HJ. So L is midpoint of HJ, which means these are bisected. These would be congruent. In other words, if this side was 5, this side would be 5. If this side was 8, this side would be 8. Like if HL was 8, then HJ would be 8. And then they give us some other information. They tell us KL is 43 minus 4x. KL is 43 minus 4x. And they tell us that GJ, the bottom here, is 9x minus 50. And then they want us to find the measure of GJ. So how do we do this when we have an expression like this? Well, if you think about what we know, if we know that this is x, then the other is 2x. Let's see if I can. Have everything filled in, we have to think about what we know. Well, what do we know? We know that whatever this is twice the length of this. Think about what we know. This base is twice the length of the midsegment. Let's actually write that down. The base is twice, that means times 2, the length of the midsegment. So that means when we solve that we want to recognize that if we double the midsegment, we would get the base. So what we're going to do is 2 times the midsegment expression equals the base. And that's how you're going to solve these. If we were to double the midsegment, we would get the base. So when we set this up to solve, we're literally going to plug it in like that. 2 times our midsegment, which is 43 minus 4x, equals our base, which is 9x minus 50. And then we're going to solve this equation. And if it seems hard, recognize that y'all are in high school and towards the end of your Math 2 class, and we need to be able to solve equations really well. So I'm going to open up my Calculate 84 app on my phone, and I recommend you do the same. Or if you have the graphing calculator at home, that's awesome too. So I'm going to use my Calculate X app. For those of you that still don't have it, please go to your app store, or if you have Android, you should be using the Wabbit Emu app. But reach out to your teachers. We'll help you download a good free calculator. So your Calculate 84 app to help us out. And we are first, when we solve this, going to distribute. So we need to do 2 times 43. So all you need to do, well, didn't mean to take a screenshot, is 2 times 43, which is 86. So we're going to write down 86 minus 2 times negative 4, that's negative 8x, equals 9x minus 50. And then we're going to do like we did before, which is get our x terms on the same side. Remember, the recommendation is to always move the coefficient of x that's the smallest. So if I'm looking at negative 8x and 9x, I would move the negative 8 because it's smaller. Because if we do that, most of the time we're going to avoid a negative number. Negatives, we like to avoid those when we can. So if I bring down my 86 equals here, 8x plus 9x is 17x. And I bring down my minus 50. And now we're down to a basic two-step equation where I would next add 50 to both sides. And 86 and 50 is 136. Then I divide by 17 and I get an x value of 8. Okay? Now, how can I verify that that makes sense? And I believe in the question, by the way, they do ask you what is the measure of JG? And JG is our base. So that means we want to substitute this 8 back into our expression here. So our base would be 9 times the 8 minus 50. 9 times 8 is 72. And then we are going to subtract the 50. And 72 minus 50 leaves us with 22. So JG GJ, either way, has a length of 22. But let's see if it makes sense. If it makes sense, then what should our midsegment be? Is it 11? I hope so, because 11 would be half of 22. And if that works out, that means we've done it correctly. So if I take my x value of 8 and substitute it back here, then I have 43 minus 4 times 8. So let's see what that gives us. 43 minus 4 times 8 is 11. Yay! That means we did it correctly. So our answer would be 22. All right, and we did it correctly, and look, they're doing it the same way. They're doubling the midsegment and setting it equal to the base. So if you want to take a picture of this work, if that's helpful, then you're welcome to do so. I'm going to do one more, but because I've already taught it, we're going to be able to go a little bit quicker. So I'm going to do number 2 with you, and again, remember I said to copy the picture of the triangle. So I basically have the same triangle where I've got this midsegment. I'm going to label my letters here for my vertices and the end of my segments here. And then I'm going to fill in what I know. So it says in the triangle, again, it's going to always tell you all this stuff here about Q being a midpoint and R being a midpoint of NP. That's just to tell you that the relationship is true. That if we double the midpoint, we'll get, or midsegment, we'll get the base, okay? So all that is telling you that this is true. This and the fact that these are parallel are what allow us to do what we're about to do. So QR, it tells us is x plus 13, and MP is 56 minus 4x. And we're going to do exactly as before. We're going to do twice the midsegment equals the base. Okay? So that means 2 times the x plus 13 equals our base of 56 minus 4x. To solve this, I'm going to distribute. To x plus 2 times 13 is 26 equals 56 minus 4x. I want to get my x terms on the same side, so I compare the coefficients of x. I have a 2x and a negative 4x. So I want to add 4x because negative 4 is definitely smaller than 2. So when I do so, 2x plus 4x is 6x, plus our 26 equals 56. And again, we're just solving this basic two-step equation like we have been for years. 56 minus 26 is 30. And if I divide both sides by 6, I get 5. So let's see what they want us to do with that. So it says, what is the measure of MP? So again, they're asking for the measure of the base. So I'm going to take this 5 and plug it in. So MP is 56 minus 4 times my x value of 5. So this is 56 minus 20, which is 36. And of course, if you want, you can just go right here and type in 56 minus 4 times 5. And you get 36. Okay? Now, if this is correct, that means that this should be 18. So let's see. Is that true? Is this equal to 18? Because half of 36 is 18. So if I plug in my 5, then I've got 5 plus 13. Yep, and it does equal 18. So that makes sense because 18 times 2 is 36. So MP, which is what they asked me to find, has a value of 36. So if you want, you can do the next two. If not, just go ahead and continue with the notes. Make sure you turn the notes in, and you can practice the other two problems tomorrow. So I'm just next going to go ahead and skip ahead to angles. So I want you to think about what we said about two parallel lines and angles. So this is number 5. So in my notebook, I'm going to put number 5, and it says, same basic triangle, although I have things labeled with different letters, right? So now I have D, G, E, H, and F. And again, they're just going to give me all this stuff about G is the midpoint of DE and blah, blah, H is the midpoint. That just tells us that we're dealing with a mid-segment problem where these two lines are parallel, but that, remember, creates corresponding angles that are congruent. That's what's going to help us this time. So it says, if the measure, so I'm going to highlight this, if the measure of GHE is x plus 52, and the measure of DFH, so this one down here, DFH is 96 minus 10x, what is the measure of DFH? Well, what do we know to be true? We know that these two angles are congruent because when two parallel lines are cut by a transversal, corresponding angles are congruent. So all you need to remember is that the angle ones, you're going to set these equal to each other. So if we have x plus 52 equal to 96 minus 10x, all we have to do is solve. Again, which coefficient is smaller, an understood 1 or a negative 10? Negative 10 is definitely smaller. So I want to add 10x to both sides so that we'll only have one x term. So 1x plus 10x makes 11x. And then remember, we always undo addition subtraction first. So 96 minus 52 is 44. And then if I divide both sides by 11, x is equal to 4. But what they want us to do is find the measure of the angle. And I'll be real honest, it doesn't matter. They're congruent, so the measure of both these angles is going to be the same. So if I plug in a 4 here, which is what they asked me to find, DF, the measure of angle DFH, then I'm going to be plugging it into 96 minus 10 times 4. Because I'm substituting that 4 right back into this expression for x. So this is 96 minus 40, which is 56. But certainly you can just type that in your calculator as well. So let's see if that makes sense. If I plug that 4 in here, is it also 56? 4 plus 52 is 56. So my answer, my value for these angles is 56 degrees. All right, and notice, same thing. They're just setting the angles equal to one another. And I'm going to do one more just for extra practice, and then you're done for the day. Just turn in your notes. But like I said, if you want to go back and practice this, then please go ahead and do so. You're welcome to. So here I go with number 6. So I'm going to first copy my triangle. G, K, H, L, J. And of course we know all the things that are hopefully congruent now. But they tell us that K, L, H, so this one right here, K, L, H is 7x plus 7 for this angle right here in this corner. And we know it's congruent down here. And G, J, L is 8x plus 0. Weird, plus 0. Okay. But we know they're congruent, so again, we're just going to set these equal. And I don't need the plus 0, by the way. I'll put it there. Really, adding 0 doesn't do anything, but let's see why they might have done that. So if I come over here and recognize that if I have 7x and 8x, again, I move the one that's smaller. 7x is smaller, so I'm going to move 7x by subtracting. And here, 8x minus 7x, 8 minus 7 is just 1, so I'm just going to leave it understood 1. And in fact, I don't really need that plus 0. So that's my x value. But then they want us to find the measure of KLH, which is the same one. So does it matter which one you type it in? No. In fact, I'd probably just plug it into whichever one was the simplest. So 8 times 7 is 56 degrees. Even if I plugged it in here, 7 times 7 plus 7 is 49 plus 7, which is 56 degrees, and notice they are congruent. So that's 56. So if I asked you to summarize these points, what would you say? So the two big summary points you need to know to solve these types of problems are for the sides. If I give you a problem involving side lengths, then you meaning segments, side lengths, then you need to remember that twice the mid segment will equal the base, and you're going to set that up every time. And then if I give you a problem regarding angles, you're just going to set the angle equal to angle, whatever expression they give you, and you're just going to solve. Okay? Well, go ahead, take a picture of your notes, submit those so you can get an easy 100, and then if you want to go ahead and practice the other ones, you can, but if you'd like to wait till tomorrow, that's fine as well. All right, good luck.